This is an algebraic technique called partial fraction decomposition. And the idea is it's the opposite of putting a fraction together, as you might have done before. 2 over x minus 1 minus 3 over x plus 2. You could get a common denominator, which would look like x minus 1 times x plus 2. And you'd have 2 times x plus 2 minus 3 times x minus 1, and you get together like this. The partial fraction decomposition is the exact opposite. So we start with this fraction. We want to decompose it. So first you have to factor the bottom. It's already factored, fine. So we have one factor here, they'll be added. We don't know what goes on top, so we choose A and B. Then I multiply through by the common denominator, x minus 1 times x plus 2. And the left side is going to be negative x plus 7. And the right side will be these two terms. Now I can pick any number I want for x to find A and B. So I pick convenient ones. So I'll start with positive 1. I choose that so that this goes away. So I have negative 1 plus 7 is 6. I have 1 plus 2, so 3a, and then this is 0. So that means a is 2. Then I pick another number, any number I want. So negative 2 is a good choice because it cancels out this piece. So negative 2 plus 7 is 9. Negative 3b, this goes away, so b is negative 3. Substitute the 2 back in, the negative 3 back in, and of course we get, well, pretty much what we started with. That's the whole idea. This is called non-repeating linear factors. Linear factors, you don't see them more than once. Here's another example, non-repeating linear factors. You have to factor first, though. So I factor it, x plus 3, x minus 3. I've got to find a and b. Multiply through by the common denominator, which is x squared minus 9. Pick any numbers you want for x. Start with x equals 3. Cancels out the first. You get 1 is equal to 3 plus 3b, so 6b. b is a sixth. Try x is negative 3. So if I plug negative 3 in, well, it's still just 1. 1 is equal to negative 6a, because it's negative 3 minus 3 is negative 6a. This cancels out. So I have a is negative 1/6. So I can put in negative 1/6 for a, put in 1/6 for b, and then just rewrite it a little bit. Put the 6's down below. Looks a little bit better like that. That's, again, non-repeating linear factors, which is the only kind you'll ever have to do when you get into calculus using this technique for integration. But they get a little more complicated here. This is called repeated linear factors. Still a linear factor, but it's repeated twice because it's squared. You need to have one fraction per power. So it looks like this. This is how you take it apart. So we still have to find a and b. So again, choose convenient numbers after you multiply through by the common denominator. So a good number is 2. If you choose x equals 2, you get 5 on the left, b on the right, so 5 is b. Now there's no other obvious choice at this point, so just choose an easy number, so something like 0. So we can also plug in that b is 5. So we have 3, because 0 plus 3 is 3, is equal to 0 minus 2a plus 5. We solve that for a, and we get a is 1. Go ahead and put in your 5 here, your 1 over here, and we get this partial fraction decomposition. So that's repeated linear factors. This is another repeated linear factor example. So the bottom's factored, so I've got a over x. I've got a b over x squared. Multiply through by the common denominator. Plug in numbers for x, such as 2 is a good choice to cancel out these two. You get c as a fourth. 0 is a good choice to cancel out these two. And you get b is 3/2. Then you need to pick one other number, given that you already know b and c. I pick 1. Plug 1 in, along with your values for b and c, and do the algebra to solve out for what a is, and you get 3/4. And finally plug the 3/4 in, the 3/2 and the 1/4, and just make them look a little bit nicer by putting the denominators in the denominator. Okay, this is now a non-factorable quadratic. Now, if it's linear, you have first power, or 0 power on top, a times x to the 0. If it's quadratic, you have to have a linear on top, so bx plus c. But now the technique is still the same. Common denominator, pick numbers for x, solve for your constants, pick some random numbers if you have to, little ones, and then eventually you plug them all back in. But the idea is you need a bx plus c. This would be a setup. We wouldn't actually do this one. If you factored the whole thing, you'd have an a over x minus 2, x minus 2 squared, x minus 2 cubed, because actually this could be factored even farther, x minus 2 to the fourth, because this factors x minus 2 squared, ex plus f, because that's quadratic, and then gx plus h, because that's quadratic. The very last thing is improper. If it's an improper one, you have to divide first, so you do long division, and then do partial fractions with this piece here.